Today I'm going to talk about friction. You can see in the picture, a guy is pushing a huge box. So what are the reactions on the box? The upward is normal reaction, R. The downward is mass of the box times gravitational force, mg. You can see the guy is pushing the box to the right. So the right arrow will be force, F, and the opposing force will be on the left, which is mu, also known as friction. First, what is friction? Friction is the force resisting the relative motion of solid surfaces, fluid layers, and material elements sliding against each other. It acts at the surface of separation of two bodies in contact and tends to oppose the motion of one over the other. Friction is an electromagnetic force generated by the charged particles of the materials in contact. What are the types of friction? There are two types of friction: static friction, μs, and kinetic friction, μk. What is static friction? Static friction is also known as limiting friction. It occurs when there is no motion, and the formula we use will be F equals to μsr, which is also equals to mg. What is kinetic friction? Kinetic friction is also known as the dynamic or sliding friction. It occurs when there is motion, and the formula we use will be F equals to μkr equals to μkmg. So you might ask, what is mu? Mu is the coefficient of friction, whereby we use the short form COF. Now, let's move on to procedure.
So, the procedure for part A, which is friction properties, we read the procedure wisely and carefully until you get the result for the A experiment, for the part A of experiment properties, friction properties. So, click the following, that link. So, I already clicked the links and got the virtual frictions. So what we have to do is the experiment say when the box is not in motion, apply force in direction in 50 Newton. So by using the mass of 50 kg. So what we have to do is take all of this, take so apply force is 50 Newton, and you can see this friction force is 50 Newton, negative 50 Newton because of the behinds of that, and the sum of force is 0. So the result that I get is same, negative 50 Newton for static friction force and 50 Newton for applied force, and sum of force is 0 Newton. So for the second, when the box in motion, max friction, as you can see, is negative 94 that I get, and applied force is 150 that the procedure said. Increase the applied force to 150 Newton. So I demo it, 150 Newton. See, applied force is 150 Newton, friction force is negative 94 Newton, and sum of force is 56 Newton. I pause it. So I get the result is same. And for the third is when 100 kg box in motion, and the speed is same with the before that. So we just include the box on the box, and applied force is 150, and as you can see on here is applied force is 150 Newton, and the friction force is negative 188 Newton for the mass of 100 kg because of two box that I have to use. Okay, never mind, I can replay it. So take all of it, take the another box to get 100 kg mass. Applied force is 150 Newton, and what I can get is 150 Newton. Just apply when in motion, so drop it again. As you can see on here, when the speed are running, so the motion it have on it, and we plus the another box. So what we get on here is negative 188 Newton meter, and the constant of speed is 189. So this is how I get for the third part. And the fourth is when I apply, the force is maximum. As you can see on here, maximum, and because the maximum of Newton on the virtual is 500 Newton, by using the on the 100 kg box, so it's same. And north surface friction, how the north surface friction doing is we apply the 500 newtons, as you can see on here. See, well, we have this, the box is still constant, means that box is still moving with constant speed. Until when, we don't know, because the speed is still same like in skating motion. So another example of for the lot surface, as you can see on here, lot surface, okay, we apply another box, maximum to 500 Newton, and we're going to lots for the friction, take all of it, see. Okay, so the difference between the non-friction and the large friction, which is the large surface friction, is the box stop after some time. Okay, we're waiting until they stop. See, it stop. Okay, this is how I'm doing for the part A for the experiment. Part A is friction properties. Thank you.
Today I'm going to do part B, coefficient of static force. First, we must click the link that were given in the procedure, this link. After you click the link, click on the force and choose inclined plane with friction to masses and pulley. After that, set angle to 0 and mass 10 kg, and surface of wood is 0.25, coefficient of friction between M2 0.25, and M1 is 10. Okay, it says slowly reduce the mass of M1 until it's barely moving toward to M1. Record the weight of M2 in table B1. So if we click the run, the speed of the M1 is going fast, so we must reduce the mass of M1 to make the M2 barely moving toward to M1. So on our lab, we use 2.6. Okay, it shows that M2 is slowly moving toward to M1. So for table B1, wood box on wood surface with 0 angle, this is what we get on the link that were given, and this is result for table B1, wood box on wood surface with 0 angle. Next, we must change the angle to 30 degree angle. Okay, repeat the step for B1. That is M2 is 10 kg and M1 is 10 kg with coefficient of 0.25. Then we click run. Okay, show that M1 is moving fast toward the ground, and we must change M1 to make M2 slowly moving toward to M1. So our lap ingot is 7.2 kilogram. It shows that M2 is barely moved toward to M1. Okay, this is for table B2, wood box on wood surface with angle 30 degree. This is what we get on the link that we were given. Okay, for table B2 that were given in our lab, for wood box on wood surface with 30 degree, this is what we get from the lab that were given.
Hello and hi, I want to share you procedure part B, coefficient of static friction continues for the table B3 and B4. For the table B3, you need to see the step 8, what is set angle to 0 degree and mass of M2 is equal to 10 kg. COF between M2 and surface is 1.0 for dry concrete on rubber. Okay, for the part B, firstly you need to click the following link that is given in the lab. Okay, after you open the link and then you set the mass M2. For the example, M2 is 2, and then mass of M2 is 2, and you click show numerical value, and for the coefficient friction you set 1.0, angle of this B3 is 0 degree, and you click run. And mass of M1 you need to adjust until the object will move. So that the object move at 2.1 kg. That after you fill for table B3, you need to continue for table B4. For the table B4, you need to set angle is 30 degree and the M2 is 1.0. For the example, I want to take weight for M2 is 2 kg, and then you open the simulation and you set M2 is 2 kg. The angle is 30 degree, and for the EOF between M2 and surface is 1.0, and then you need to run the simulation. For the mass one also you need to adjust slowly until, and then for the weight 2 kg, the object will be moved at 2.8 kg for M1. Okay, for the M2 we need to change to Newton, and the formula is F equal to M times by G. M is weight for the M2, this is 2 times by G is gravity, and the gravity is 9.8, and the answer is 19.6. And same with M1, you need to put the M is 2.1 and then times by 9.8, and the answer is 20.58. Okay, for the table B4, it use same formula for M2 and M1.
Now we start question 1. Plot M2 versus M1 using the data from part B, then calculate mu s, which is coefficient of friction, for every cases. So, by the table that we have calculated just now, we just insert the value into Excel and plot a line graph. Your graph will look like this, and you can see it increases linearly because it did not pass through 0. So how do we calculate mu s? Mu s is the gradient of the graph. So, gradient, you have to draw a big triangle, and you take the highest value minus the lowest value. So the formula will be y2 minus y1 over x2 minus x1. So y2 is 98 minus y1 19.6 over x2 25.48 minus x1 5.88. You calculate it, you will get 4.00. This is the gradient of the graph, which is mu s. The gradient of the graph does not have a unit because Newton over Newton, you won't get any unit. Now moving on to table B2. You also insert the value in the graph, plot it, you will get a graph of increases linearly also. The same thing, y2 minus y1, 98 minus 19.6 over x2 minus x1, 70.56 minus 14.7. You will get 1.40. Same goes to table B3. y2 minus y1, 98 minus 19.6 over x2 minus x1, 98.98 minus 20.58. You will get 1.00. And lastly, table B4. y2 minus y1, 98 minus 19.6 over x2 minus x1, 135.24 minus 27.44. So the final answer you get is 0.73. So this is how we do question 1.
So for the question of 2, which is state what can you observe from the values of COF from the experiment. COF is coefficient for static friction. My answer is when static friction is high, the force required for sliding is less. So that is the answer for the question 2.
For question 3, state the effect regarding on the type of material to the value of COF. So the answer is wood on wood has lower COF value compared to dry concrete on rubber because wood has rougher surface compared to dry concrete on rubber. The smoother the surface, the higher of COF value, and more force is needed to apply to stop the object from sliding.
Hello, and we continues for question number 4. The question is, state the main error that will affect the result from the experiment. For this experiment, the error is random error. Is that human reading error and reaction time. Why I say human reading error? Because when we read the measurement reading, it is not necessarily the measurement that is accurate. That's why the error is from human reading.